Hey guys, how's it going? Welcome back, math fans. Let's go over our welcome work first. Hopefully you've already completed that. If you haven't, I'd click pause right now and make sure I finished it first. Number one says write three ratios, remember ratio means fraction, that are equivalent to 4/6. Well, I can think of one. I can just reduce that. I can reduce that fraction. I get 2/3. I could multiply the top and the bottom by the same number. How about 8/12? I multiplied the top and the bottom by 2. I could also do that again. Let's multiply it by 3, 12/18. And my favorite one, I did 4. It said 3, but I did 4. All these are ratios. How about 10 and 10? 40 over 60. All those are three ratios that are equivalent to 4/6. All right, we're back to our real fun problems. Solve each of the following equations. Remember, this is a two-step equation. It's fun, fun, fun. What we're going to do, draw your line. Remember, we subtract 4 from this side. Same. Subtract 4 from this side. We're left with 3x on this side. 3x equals 17. Divide this side by 3. Divide this side by 3. And we're left with x equals. I can really just leave it like that, 17/3, or I could reduce it. 3 goes into 17 5 times. I have 2 left over, and my original denominators are 3, 5 and 2/3. Let's go over here. This time we got to move some numbers from one side to the other side at the same time. Let's go ahead and draw our line. I'm going to subtract 2x from this side. Why? Because I want to make sure I'm working with a positive x on this side. Same. Those cancel each other out, so I'm left with negative 13 on this side equals, well, 3x minus 2x is just 1x, right? I still have my 18 over here. So now how do I get the 18 over there? Well, it's the opposite of positive 18. You guessed it, negative 18. Same. Remember, when we're adding integers like this, these will cancel each other out. I'm left with just x on this side. And over here, negative 13 and a negative 18 is a negative 31. Did you get that right? I bet you did. And for our last one, of course, we love this. CCAS, crisscross applesauce. I'm going to go ahead and cross multiply those. 3 times 51 and 6 times x. When we go ahead and do that, we get 6x equals 153. I'm then going to divide both sides by 6, because what's the opposite of multiplying by 6? Divide by 6. Those cancel each other out. And 153 divided by 6 is 25.5. Did you get all those right? I bet you did. All right. Now we're going to sketch the following figures. The last one. A square, a triangle, a parallelogram, a trapezoid. Hopefully you know the difference between those. A parallelogram, a trapezoid. Of course, a right angle we know is always right. And an angle. Ready for some magic tricks? Bam! There's a square, a triangle. Here's a parallelogram. Looks like kind of a rectangle someone sat on. Trapezoid, a right triangle. This is the most important part of the right triangle. It's got that little square in the box that lets you know that angle is equal to 90 degrees. I bet you got all these right too. And a 50-degree angle, it's not important that you got this exactly right, like you didn't have to use a protractor, but just the fact that you knew that this angle was less than a right triangle. All right, grab your book. We're ready to go. We're going to take some lessons. Please take notes in your book. If you did not grab your book yet, I'd grab your book now. Press pause. Once you're ready to go ahead and hit start again. All right, today we're talking about angle pairs, not angel pairs. I don't get it. Get it? Angle pairs, angel. I'm kind of waiting for you to get your book out. We're on page 137. I'll get rid of these angels. I'll get rid of their jokes. They really weren't funny anyway. All right, math fans, angle pairs. We're going to be talking about complementary, supplementary, and adjacent. So basically the sum of this whole page right here, we already know that an acute angle is cute. It's small. It's less than 90 degrees. Oh, that's so cute. We know a right angle, especially from our last page, is 90 degrees. It's got a little square in the middle to let you know that. And an obtuse angle, it's obtuse. It even sounds like it's drawn. It's bigger than 90, but less than 180. Let's go over some vocabulary words. I really need you to write these down. Once I remove this box, press pause and copy down all these definitions. I'm going to go ahead and move this right out of the way for you. Here are some common terms. An angle. An angle is where two rays meet. Like right here. Here's a ray. Here's a ray. They meet together. How you doing? Good. Nice to meet you. They meet and they form an angle. A vertex is the place where those two meet. So letter B here is the vertex. It's the place where two rays meet. Complementary we're going to talk about in a couple minutes, but that's two angles that equal 90 degrees. Two angles that equal 90 degrees. Supplementary is two angles that equal 180 degrees. And the word adjacent is just kind of a fancy word for next to each other. Press pause now and make sure you've got all 5 of these definitions written in your math book. I'll wait. Hey, great, man. Thanks. Welcome back. It's good to see you. I'm glad you got that written down. We're still on page 137. It says some angle relations have special names. We know that complementary means it equals 90. We know that supplementary means that it equals 180. And if you get those two terms down, most of this lesson will be really easy for you. Did you get it? I knew you did. Go ahead and turn to your neighbor and tell them what a complementary and supplementary angle means. I bet they'll be impressed at your knowledge. We're now on page 138. Page 138, I'm on number 3. I'm going to do it with you. It says name pairs of angles that form complementary or supplementary choices. Remember, the word complementary means 90. And the word supplementary means 180. So we've got to find ones that equal that. So let's see if we can find some. Oh, I see some right away. So excited. A and G equal 90. So A plus G, 53 plus 37, that equals 90. D and E equal 90. So 31 and 59, if I add those two together, I get 90. What about B and F? Angle B is 90. Angle F is 90. If I add those together, I get 180. So those are supplementary. And A and H, 137 and 143. If I add those together, I get 180 degrees. So those are supplementary. So these sets are supplementary. What's up? And these are complementary because they equal 90. That's kind of a weird looking P, isn't it? There, I fixed it. All right, since you got that down, let's keep rolling. We've already got these definitions, but go ahead and put a star on there. I'm on page 138. Sorry, I'm glad I didn't do that in your ear this time. A pair of complementary angles, if they're complements of each other, it means they equal. What do they equal? 90. And you just have to put a star there because you've already copied down these definitions on the front page of your book or the chapter. And a pair of supplementary angles, these are 180. So let's look at these questions they ask us. 32 degrees. What's the complement? Meaning 32 plus what equals 90 degrees? Its complement is 58 because 58 plus 32 equals 90. Does it have a supplement? Yep. Its supplement is 148 because 148 plus 32 equals 180. Let's think about B. B is 113 degrees. Does that have a complement? No. It's already greater than 90. It can't have a complement. Complement? Not. But it does have a supplement. The supplement is 67 because 67 degrees plus 113 degrees equals 180. Uh-oh, they're throwing some decimals at us. I might have to get out my calculator for this one. What angle plus 68.9 equals 90? How about 21.1 degrees? Let me get my calculator out again. 180 minus 68.9 is 111.1. So the complement of 68.9 is 21.1 because those equal 90. And the supplement of 111.1 is 68.9 because those equal 180. I know, this is easy stuff. I know you got it. It says, why are angles 1 and 2 in this diagram complementary? Well, they're complementary because this plus this equals 90 degrees. Why are angles 1 and 2 in this diagram supplementary? Because angle 1 and angle 2 equal 180. 180 degrees. Let's look at number 7. Which of the following is a pair of adjacent angles? Adjacent means next to. We know that. I put a star by this on page 139. Adjacent angles have a common side, meaning they're next to each other, and a vertex. So they have to meet at the same point. Well, the vertex of this one, 1 and 2, they're adjacent. Is this one adjacent? Do they share the same vertex? No, they do not share the same vertex. Those are not adjacent angles. This one is? Yay! This one is not. So adjacent means next to each other, and it's got to share the same vertex, which is a point. Let's flip over to page 140. This is where it gets a little tricky. They're telling you two angles are complementary. What does complementary mean? They equal 90. One measures 2x. Uh-oh, that sounds complicated. And the other measures 48 degrees. It says draw a pair of adjacent, which means next to, complementary angles and label them. So they want you to have a drawing that basically means they're complementary, right? They have to equal 90 to be complementary. And I got to draw two angles like that. So if you did that correctly, one of the angles is 48. They tell us that, right? And the other angle, we don't know what that is, but it's 2x. So, but we do know that this angle, 2x, and this angle, 48, equal what? 90. So let's write an equation. An equation means equal sign. So we got to write an equation to show the relationship between the two angles. And then you got to solve for that. So we know it equals 90, right? Equation, equal. We know one of the angles is 48. And we know the other angle added to it is 2x. We know they equal 90 because that's a definition of complementary. It equals 90. I'll go ahead and give you the cleaner version of that. 2x plus 48 equals 90. And we know how to solve for that. That's like a regular two-step equation for solving for x, right? We draw our line, we subtract 48, and then we go over here and we divide by 2. And when we do all that, we know we get 21. In other words, x equals 21. So 2 times 21 is 42. 42 plus 48 equals 90. And the last part, they tell you what are those measurements, but we know that. We know that 2 times 21 equals 42. And the second angle is 48. That's an easy one. They told us that. You ready for one that's really hard? We're still on page 140. Hit pause and try this one on your own. It's supplementary. You know that supplementary means 180. So try to figure that one out on your own. Hit pause. Great job. Welcome back. So draw a pair of adjacent, meaning next to each other, supplementary angles, meaning 180, and label them. Your drawing should look just like this. They told you one of the angles was 123 degrees and the other angle was 3x. Hit pause again and write the equation. If you need to flip back, flip back. because you already wrote it in your book for number 9. Hey, welcome back. Did you write it like this? 3x, this angle, plus 123, this angle equals 180. And then we solve for x. We know that x is 19. Hit pause again. Hey, welcome back. The first angle, 3 times 19, is 57 degrees. So this angle up top right here is 57. And this angle right here, 123, that's the one they gave us. Those two angles together equal 180, because that's the definition of supplementary. Let's do some more. Your homework's in the back. Have a great evening. Way to go. I hope you took notes on this. If you took notes, you're probably on your way to an A. I don't know why these guys are busting on me right here. Have a great one.